Hello again. Welcome everybody. CSEC Math Prep here again. And we're on to our fourth video. So far, we have covered computation number theory and consumer, algebra, geometry and trigonometry. And for this fourth video, we'll be covering functions and relations and graph. Now, here I'm going to show you the most popular topics that we see under this category here, function, relation, and graph. Parabola, right? And everything related to it, roots, minimum, maximum point, axis of symmetry. We have linear graphs, y-intercept, length of line, gradient, midpoint, equation of line. And of course, concerning functions, we have evaluating functions, composite functions, and the inverse of a function. If you know most of these concepts or all of them, then you are absolutely safe for the function and relation category here. As we go through, what you're going to realize is most of the questions will take in these concepts that you see here. Now, there is no question that will take in all of them, but the question will be capturing probably two of the three columns you see I have here, right? All right, so let's go now for functions and relation and graph. All right, this question here is a question you normally see in the algebra section. We have done one like it before in video 2, if you remember, if you have gone through that video so far. But for this past paper question here, what happened is that it is present in this function area here. In fact, we're going to cover it nonetheless. All right, so the incomplete table below shows one pair of values for A and R, where A is directly proportional to the square of R. And we have A, we have 36, a complete ratio given, and the value for R is 3. All right, the three questions here before I even pull up my work pad here. Express A in terms of R and a constant K. Calculate the value of K and copy and complete the table. All right, so we'll be focusing on all of that here in our work pad. If you remember from the time, by the way, from video 2, when it's direct variation, right, or proportionally or directly proportional, we use a formula. You remember it? It's y equal kx. And if it's indirect variation, y equal k over x. And that is at its basic. Now, for this specific question, I say A varies directly proportional to the square of R. And then to express A in terms of R and a constant K, all we're going to have is this. A equal KR squared, right? So it's not just directly proportional, it's directly proportional to the square of R. So we'll just include that R square factor in, sorry. So given that, everything else in this question, right, is forthcoming. So A is equal to the to KR square. And we have a complete ratio, right? 36 and the 3. And what we do here is just put 36, that's the A value. The K value we don't know, but we know that R is 3. And what we're going to do is that we're going to square R as the definition is there. A is KR squared. Now 3 3s is 9. And since we want to make K the subject, you already know that what we're going to do is divide both sides by 9. And then we're going to have the K value being 4. So 9 cancel 9 at the K there, and 9 and 36 goes 4 times. And that's our K value. For most of these questions, whether it's direct or indirect variation, one of the first thing will be required is for you to find the value of K, right? Well, after you figure out the formula, that is, whether you're doing indirect variation or direct variation. Now that we have a value for K, almost everything else we can find. So calculate the value for K is done, 2 marks. And then there is this value given for R, which is 5. And above, right, is this missing value for A that we should find. But since we already know that A directly proportional to the square of R, we're going to have A equal K 5 squared. Naturally, no, we're very used to writing 5 squared K. But because I want to have them in the exact way the formula is right here, just for persons who may not see this readily, right? So we know that K is 4, and we are squaring the 5. 5 is 25 times 4. And the value of A is going to be 100, right? Quite easily done. And then the value for A is given as 196. And then they're asking us to find what the value for R would be, since it's directly proportional. Now, the formula stands A is equal to K R squared. And in this case, we have the A value 196. And then we know the K value is 4. And then R squared. That value R is what we want to find now. We're going to divide both sides by 4 first, so that we can have the R standing by itself, right? When we do that, 4 cancel 4 on the right side, and then on the left side, we have 196 divided by 4. It's going to give us 49, right? So we're going to have 49 is equal to R squared. And then when we square root both sides, R squared when square root is applied will give us just R. And then this root of 49 is 7. And that completes that. My recommendation is, is to hide the answer from yourself and just try and see if you could follow the steps through, find what the formula is, or at least write it down, and then find the missing values using that direct proportion formula. But that completes that question for 3 marks. And then on to part B, that function question there. All right, now I want you to pay attention because I'm going to show you a number of ways to approach these questions here. Beyond this, I'll just use one method, but I'm going to show you 2 for both of them that you're seeing below here. All right, so the fx function is giving us 2x plus 1 over 3, and the gx function 4x plus 5. And the question is asked for us to find fg2, right? All right. Firstly, I'm going to show you we're going to approach it. Now, that this is a composite function, by the way, putting a function into a function. So what's happening here is that the function f is 2x plus 1 over 3. As you can see, we have the 2 here, we have the plus 1 here, and the 3 being dividing here. But in this space here, where the x was, we're going to be putting all of this g function into the x space. That's what fg means here. It means that we're putting the g function into the f1. All right, so when you put in that 4x plus 5, it will look like that. And then what we're going to do is expand the bracket there. 4 2's 8x, and 2 times 5 is 10. Plus 1 divided by 3. Now, there are some like terms there, the 10 and the 1. They are like terms, so we can add them. And then what we're asked to do here is to put 2 into that combination function. So after you put the g into the f function and simplify, then they're asking us now to put 2 into the x place. So 2 times 8 is 16 plus 11. That's 27. And when we divide 27 by 3, 9 is our answer. So the value for fg2 is 9. Plug this g function into the f function, and then put 2 into the result, and then we end up with this. Now, there's another way I'm going to show you. And beyond that, you can just select whichever one of the ways you want. All right. For this, if you notice, there's g2 at the beginning of the question here, right? What it's saying to us is that we should put the value 2 into the x place of a g function. So we have 4 times 2 plus 5, right? Putting 2 into the x place. So 4 2 is 8 plus 5. Our answer is 13. Now that's for g2. Now the value of g2 is 13. And the question says, right, fg2. In other words, it's asking us to find what f13 is. So g2 is 13, and what you're going to do is put that 13 to the f function now. which is 2x plus 1, which is 2 times 13 in this case, the G2, right? Plus 1. 2 times 13 is 26 plus 1, 27, and we divide that by 3, we end up with 9, just the same. So the approach is up to you, whether you want to put the function into the function first, and then put 2 into the result, or you want to put 2 into the first function here, ascertain a value, then put that value into the second function, ending up with the same answer nonetheless. So we capture our other 6 mark in doing that. All right, now I think I'm jumping the gun here. Right, so the other part of the question is asking us to find f inverse 3. I'm also going to show you 2 ways to approach this one, right? So the first one, the concept was composite mixed with evaluation, but this one is asking us to evaluate the function here as well. But it's the inverse that they want us to put the value 3 into. So there are 3 steps to find the inverse. I'm going to show you 2 ways to do this one as well. 3 steps to finding the inverse for a function, right? Now, step 1, because we're very used to writing the fx as y, even when you see a graph, right, the y-axis sometimes labeled as fx. The first step in this is to make fx y. So we have fx here, just replace it with the y and equate it to the regular part, 2x plus 1 over 3. That's the first step. Nothing much there. The second step is also nothing much. We are going to be interchanging the x value and the y value. So instead of having y equal, we're going to have x equal 2y plus 1. So where x is put y, where y is put 2. And then final step is to make y the subject. In other words, we're going to transpose this second formula here now to let y be the subject. First step is to multiply 3 on the left side, or multiply 3 on both sides. Same thing as carrying this 3 over there and multiplying it, ending up with 3x equal to y plus 1. Now, having this, we still need to let y be the subject, so there's more work to be done. And what we're going to do at this point is to subtract 1 from both sides, giving us 3x minus 1 equal 2. Still need to do a little bit more to get y to be the subject, which is dividing both sides by 2. And what's going to happen is 3x minus 1 divided by 2, and that's our inverse, right? So if we notice, just by looking, we have 2x plus 1 here. 2 is multiplying, 2 is dividing. 2 is adding up here, 2 is subtracting here. 3 is dividing here, and 3 is multiplying here. The total inverse of what the signs were. Now, there's another way to do it. And if you aren't keen on noticing exactly what's happening here, I wouldn't advise you approach it like this. What we're going to be doing here is this. Oh, by the way, there was a value, right? Right, there was a value supposed to be substituted in this here. So 3 times 3 is 9. And 1 from 9 is 8, and 8 divided by 2. Right, so the value after we have found the inverse would be 4 here. All right, so as I was saying, 2x plus 1 over 3 is the original function, right? And what they want us to do is to put 3 to the inverse to find the value. Now, whenever we see f inverse 3, another approach is, instead of finding the inverse for this function, what we can do is equate the original function to 3 and then solve it. Now, in doing that, right, what we're going to do is multiply both sides by 3, and we're going to have 2x plus 1 equal 9. So if you notice in this, we're not finding the inverse for it, right? We're just equating the original function to 3. And then from here, we're going to subtract 1 from both sides. So we have 2x equal 9 minus 1. 2x equal 8, and we divide both sides by 2. We're going to end up is 4 just as before. So the inverse of f, when we put 3 into that x place there, will end up give us a value of 4. And that's it. Now we can approach it any one of these ways. You can find the inverse first and then plug your 3 into it. Or we can equate the original to 3 and then finding the value for x there. All right, so that's it. We're warming up the function, but as I said, what we have done here, right? Evaluating composite and inverse function, I showed you on the list before. These are most of the things that CSEC tests for, most popular ones, concepts, right? All right, great. Let's move on to the other question. Now, for this question, the construction is normally under the category measurement, right? But for this, it seemed they had it along with the functions for this specific year. What we're gonna do is I'm still gonna work it and then continue with our functions concept, right? All right, so if you want to follow ahead, grab your tools, your ruler, pencil, compasses, because what they want in this question is for us to construct triangle PQR, where PQ is 8 centimeters, PQR 60 degrees, and QPR is 45 degrees. It's a very compact question. Most of the time, CSEC asks us to construct 60-degree angle and a 90-degree angle. This question is no short of that, because in constructing a 90, we are able to construct a 45 degrees through bisecting. So first, we draw 8 centimeter line. You can follow using a compass and ruler if you possess them. And then we are going to be 8 centimeters. And then what we're going to do now is grab our compass. So this is the line PQ, right? And we're going to, it says PQR equals 60 degrees. That means that 60-degree angle will be at point Q. I'm going to put the compass at point Q, the point of the compass, and then make a swing, cutting that line, right? When we swing and cut that line, then we're going to put the compass at the point where the arc cuts the line and make a swing again and cut that arc, one that we made first. From there, what we're going to do is just draw a line from point Q going to the point where the arcs meet. All right. Easy so far. You can grab your ruler and try. Please ensure that the compass does not shift in the process. If it does, then you kind of have the wrong measurement, right? You can check with the protractor, of course, to ensure that it is 60 degrees. Just to check. So 60 at point Q. Now, at point Q, PR, 45 degrees. That's on the left side of the line. And to do that, what we're going to do is extend the line using dotted lines, right? Extending point P. Then we're going to have the compass at point P, and we're going to swing, make a swing, cutting both lines. So making a swing, right? Just like that. From one end of the solid line, go to the next, cutting the broken line, or from the broken line over to the solid line, right? Nice, neat little arc. And what we're going to do then is put the point, the point of the compass at the point where the arc cut the line, right? Right there. And we're going to make a swing up. Oh, yeah. By the way, you're going to open the compass a little bit wider from what it was originally. Open it wider and then swing above point P. And then we're going to put the compass on the other side and then swing above point P again and cutting that arc at the top. Then take the ruler and just whoop from point P going to where the arcs meet. And that's our 90-degree angle, right? Now, 90 is not what we need. Remember, we need QPR to be 45. What we're going to do now is that we're going to use these 2 points. We need a common arc to bisect 90 into 2. So we can get the 45 degrees. So we're going to use this point, and we're going to use that point right there. So now this point is these points are points from a common arc. Whenever we're bisecting an angle, we need points from a common arc. So that's a common arc, and we're going to just put the compass and swing out in the middle there. And the compass at the other point, you see the red dot there, and swing out in the middle. Now forget the ruler and just connect point P through where the arcs meet there. And there we have point R, PQR, and 45 degrees there, the bisecting. And there we have it. So that's triangle PQR, point Q 60 degrees, point P 45 degrees. And then 4 marks. Measure and state the length of QRQ for 1 mark. Just grab the ruler and measure there. Now, mine is saying what here? 5.1. Your measurement would be more exact. Please check to ensure. And then you, bam, easy 1 mark. And that's the construction. You may want to practice putting the 60 degree on the right side, on the left side, and practice the 90 degree on the right side in case CSEC asks for such. But that's that for the construction. And we're moving on to another part of the question here. That was part A. And part B now is the length. The line L passes through points 6, and 0, -2. All right. Now the question is asking us. So that's 2 points on the Cartesian plane, right? Determine the gradient of the line, the equation of the line, the midpoint of the line, and the length of the line segment TS. This question is rather straightforward. Now there's another question coming up that is not so straightforward. They give us 2 points here and then they ask us all these things about it, these features. So let's go. So for the gradient is defined as a slope, right? The measurement of slope, slopeness of a line. So the point S is 6 and the point T is 0, -2. Now at point S, right? The first 6, that's the X coordinate. And the second one is the Y coordinate. For T, the first one is X2 and the second one is Y2. If they are labeled like that, then we can find the gradient using this formula. We always have this say that the gradient is the ratio rise over the run. And all we do is putting in the respective numbers in the formula here. So Y2 is -2 minus Y1, which is 6. And X2 is 0 minus 6, which is X1. And then -2 minus 6 is -8, and 0 minus 6 is -6. But both numbers are negative in that fraction there. So it's the same as having positive 8/6. And that's the gradient, 8/6. I wouldn't convert this to mixed fraction. I revert to the fact that we may need to use it again. It's fine being a fraction like that. 2 marks. Of course, that's part of the question. Now, to find the equation of a line, the equation of a line is defined as y equal mx plus c. Y equal mx plus c. Now, in writing the equation of a line, we only need 2 values really. We need the m and we need the c. Now, x and y are just regular coordinate points, right? So on a line, there are many points. At every single point, there's an x coordinate and a y coordinate. They'll be different based on where you are on the line. But the gradient and the c value will remain the same at all times for that specific line. So the moment we have the gradient and c, then we have the equation of the line. We have already found the gradient. The gradient is 8/6. So what happened is we don't know what c is. So we know if we use point S into the equation, right? Using y as 6 and x as 6 as it is in the coordinate above. We put the 8/6 where the gradient is, that's the m. The c is the only value that we don't know. But since we have all the other information, the 6 for the x and the 6 for the y, and the gradient, we can just solve this equation to find C. So beyond this, what we're going to do is cancel the 6 and the 6 there. And then we end up with 6 equal 8 plus C. And then we're going to subtract 8 from both sides. And C is now equal to minus 2. Given that we know what the gradient is, 8 over 6, and we know that C is minus 2, we can now write the equation of the line. It is y equal 8 over 6 x minus 2. That's it. Don't forget that when you write the final expression for the equation of a line, there is no value that we're going to place in the y and the x place. We leave those as variables because they vary, but the gradient and the y-intercept will always remain the same for that specific line. And that would be your answer. 2 marks. Now the midpoint is another feature of the line commonly asked. And this is the formula that we use for midpoint. It is x1 plus x2 divided by 2, then y1 plus y2 divided by 2. The 1 and the 2 and the x's really don't matter at this point. You're just adding both x coordinates from the points. So 6 from this side, 0 from the other. Those are the x coordinate, and then 6 and then minus 2. When you add those, right, 6 divided by 2 is 3 and 4 divided by 2 is 2. That's a midpoint. All right. Finally, the length of the line is given using a formula as well. Now, when you draw a line naturally, if it's diagonal, you can form a right angle triangle from it. And since you have a run and a rise, then we can use this formula to find it. The formula may look complicated, but it's rather simple. It comes from a concept called Pythagoras theorem. For those who watch the third video, which is the video before this one, there are a number of times when the Pythagoras theorem would have been used. So it's a square plus b square equals c square. And then after you square and add, then you would find the square root. Remember that? That's what's being applied here. Now, this is how I'm going to make it easier for you to do when finding the length of a line. The gradient is 8 over 6. That top number there, remember from the gradient formula, it was y2 minus y1. That's the same thing that happens here in the length formula. And the bottom number, x2 minus x1 in the gradient, it's the same thing that is being applied here in the length of the line. So the 8 and the 6 that you have in the gradient, you can actually use them in the equation for a line, and you still end up with the correct answer, right? But for some people who probably had simplified this to 4 over 3, you'd be in problems in applying it here. You'd get the length of the line halfway. So if you left it like this, right, then you can just work from there, right? So 8 squared, 64, and 6, 6, 36, which is 100, and the square root of 100 is 10. So the length of the line is 10. Again, you can go through, look back through these formulas, get familiar with them. They will be tested at some point on the exam, right? There is the concepts here, right? The formulas that are given, none of them will be on the CSEC exam in terms of the formula sheet. These don't come. You have to remember these from memory, right? Okay, I'm going to show you another way we could have found these answers here. Because what CSEC do is sometimes they give you the line, right? And they ask you the questions. In this case, what they did was just to give you the points. But for some students, what they would have done, they would have gotten a graph paper, plotted the 2 points, right? So that's the 6, 6 point. And this is the 0 minus 2 point, right? Now, when you have the line, you still can ascertain all the things that they're asking here. So first was the gradient they're asking for. As I said, gradient was a measurement of slope, right? Rise over run. And if you start counting here, 1, 2, 3, 4, 5, 6. So the run is 6 and 1, 2, 3, 4, 5, 6, 7, 8. And the rise is 8 based on our count. So the gradient, therefore, is 8 over 6. M is the letter used for gradient, by the way, in coordinate geometry. So it's 8 over 6, and as you can see, it was a run and the rise, and we put the rise over the run using the line. And this way you don't use the formula, right? All right, the equation of the line. You only need two things, remember, the gradient and the y-intercept. Now we just find the gradient using the run and the rise. And the y-intercept, it just simply means where the line cut the y-axis. It's right here at -2. It was obvious since the x-coordinate was 0, right? So when you draw a line and you see the y-intercept there, you just put the gradient in its place and the y-intercept at the end there. And that's the equation of the line, even without working out anything with the formula. The midpoint of the line now is just simply halfway the run and halfway the rise. And that point is 3, 2 there. All right, the length of the line now. Naturally, there's nothing you could look at there and just figure the length of the line out. You have to grab the ruler and measure it, all right? 10 centimeters. Now, that was just an alternative way to do this question if you want to, if you don't remember all the formulas. All right, very good. When you have the time, please go back through in case I was going too fast just now. All right, functions f and g are defined as 2x minus 5 and gx is x squared plus 3. Calculate the value of f4, that's evaluating function. Then gf of 4, that's composite function with evaluation. And then they're asking to find the inverse of f. Are these concepts familiar to anyone? Good. Now, what they're asking us to do is to put 4 into the x place of the f function, right? So that's f4, 2 times 4 minus 5, right? So f4 is going to be equal to 8 minus 5, which is 3. See? 1 mark, easily. Very easily. Now, gf4 is a similar concept that I showed you at first when I say you can put f function in the g function here. But if you put 4 into the f function, you can put that value into the g function. Now, if f4 is 3, we already know that. All we need to do then is put 3 into the g function. Make life easier for us, right? So if we just basically finding g of 3. And 3 squared is 9. And 9 plus 3 is 12. Easily. 2 marks. No stress, no hassle. If you look at the recent CSEC papers, by the way, you will see some of these concepts being tested there. Finally, for the inverse of f, luckily, we're not asked to evaluate anything, just to find the inverse of that function there. And if you remember, there are 3 steps to doing this. 1, it was to make fx y. So instead of having fx equal 2x minus 5, we say y equals 2x minus 5. Then we're going to interchange x for y. So x is equal to 2y minus 5. Then we're making y the subject, the third step. First, we're going to add 5 to both sides. So we have x plus 5 equal to 2y. And then at this point, we're going to be dividing both sides by 2. And that will give us x plus 5 over 2. And that's making y the subject, which is our f inverse, right? Easy. Not seeing any of this for the first time. 2 marks. All right, give yourself a clap. Let's move on. All right, so here we have a parabola. This was one of the things on my list. One of the things CSEC also like to be testing for. All right, for this year, this specific year that you're seeing here, CSEC had, they gave us a parabola, and then they're going to be asking a few questions from it. So it's y squared. You're looking at x squared plus 2x minus 3. And these are the questions related to that question. Now, the first one says, the scale used on the x-axis for 1 mark. Now, on the x-axis is right here. And from 0 to 1, we notice that there are 2 centimeters being used. So the scale is simply this. 2 centimeter represents 1 unit on the x-axis, right? Simple. The second question, the value of y for which x is minus 1.5. So let's pay attention carefully. 1.5 on the x-axis is right here. And we're trying to read the information from the graphs. Therefore, at minus 1.5 on the x-axis, the y value, right? If we're looking along the y value. So we're going to read, this is minus 3. And the other line there will be minus 3.2. There are 5 movements in between the 3 and the 4 there. That means each of them is 0.2. So that's 3.2, that's 3.4, that's 3.6. And then that y value where the red line meets the parabola is 3.8. So where x is minus 1.5, y is minus 3.8. And that's our answer for 2 marks. The values of x for which y is equal to 0. Now, values of x indicates that there's more than 1. And there's another name that we call them as roots. In any case, on the x-axis, all values for y are 0. So here is really talking about minus 3 and 1. So when y is 0, x equals minus 3 and x equals 1. Now these are also called roots sometimes or solutions, right? And then the next part of the question is asking the range of values of y, giving your answer in the form a less than or equal to y, less than or equal to b. Now, the range of values for y just mean how tall the graph is in general. So the graph does not pass 5 on the y-axis, neither is it below minus 4 on the y-axis. So we're talking about all the values within this area here, right? So how you'd write that range is minus 4 is less than or equal to y, less than or equal to minus 5. So my green circles there indicate the ranges. So it's minus 4, 5. Y falls in between those points inclusive. And that's it for our question there. Nothing hard, just something you should look over. All right, now I'm looking at this page now and I'm saying it seems as if I'm definitely repeating myself. But let's start with part B. Part B of the question, Let's look back at this. The name of this function is x squared plus 2x minus 3. That's it. That was the question for that year. And what's the name of this function? This is a different year altogether. X squared plus 2x minus 3. Again, what happened is CSEC didn't give us the drawn graph this time, right? They give us a table. And what they're asking us to do is to just put in these missing values and then using the scale, 2 centimeter represent 1 unit, the same thing now discovered around there, right? 2 centimeter represent 1 unit and 1 to 1 on the y-axis, draw the graph. So in one year, CSEC draw the graph for you. And in another year, they give you the same question and ask you to draw it again. So we're not going to do that graph, but I'm going to ask you if you can find these missing values and these, and then draw the graph, right? Now the question above, part A, naturally, is something Nothing here is new. We have even seen f with 3 the same way. All right, so let's go for that one. Some of you can go ahead since you are skilled at this now. Hold on there, I'm having a little problem with my video. It seems to be stuck here. All right. Give me a minute, everybody. Something is happening. Okay, I'm back. All right, so let's continue with this question. Part A. All right, I think I know what the problem is. All right, everybody, I got this. All right, great. So we're back. All right, so for this question now, none of the concepts here are new. So what's happening now is grab our answer pad here and let's go. So f of minus 2 is what they're asking us to evaluate. And what we're going to do now is just put the 2 into the f place right there. So what we have is 2x minus 5 and g is x squared minus 31. Now, f of minus 2 is the first thing we're evaluating. So it's 2 times minus 2 minus 5. So that's 2 times minus 2 is minus 4. Minus 5 gives us what? Anybody knows? You can answer before I show you. Minus 9 for 1 mark. Now, we have gf of 1. And we are seeing this what now? Twice. Third time. What we're going to be doing is putting 1 into the f function first. 2 times 1 minus 5. Anybody knows the answer? Minus 3. 2 times 1 is 2, and we take 5 from 3 is minus 3. So f of 1 is minus 3. And what we're going to do now is to put minus 3 into that g function there. Now, when we square minus 3, we get a positive value, positive 9. And when you take 31 from 9, we end up with a minus 22. Another 2 mark. Nothing hard. Repeat concept. And finally, it was 2 ways, right, that we did for finding the inverse and then plugging 3 into the x place there. All right, so let's go. Let's find the inverse, something that we need to practice. The first step was to let fx be y. And then the second step was to interchange x for y. It's x equal to y minus 5. At this point, what we're going to do, add 5 to both sides, then divide both sides by 2. So the inverse of f is x plus 5 divided by 2. No challenge for this question at all. And of course, oh yes, we were now to insert 3 in our x place there. So it's 3 plus 5, 8 divided by 2. Our answer is 4, right? Practice without the answers to ensure that the concept is something that you understand. All right, very good. All right, so here it is now, just as the case with the parabola. In one case, CSEC gave you the parabola. In the other case, they gave you a table. For this question here, we were given 6, 6 first and 0 minus 2. Remember that line? TS. For this one, CSEC has given us a line here, and then there are some questions. So really and truly, if we understand the concept, whichever way CSEC sends the question is something that we be able to manage. The equation of the line above is y equal mx plus c. Let's just say we already know that, right? State the value of c. C is the y-intercept. We already know that. Determine the value of m. M is the gradient. We already know that. Determine the coordinates of the midpoint of the line segment AB. We already know how to find the midpoint. Not how we're going to. So first, if we look at the y-axis here, the first numbering is at 5. Normally you have 1, 2, 3, 4, 5, so on, but we have 5 here. That means at point A, the y-intercept is 7. So the line cut at this point, it's at 7. That's part 1. Question 2 was asking for the gradient. We could do the run since the line is here, but let us say we're going to be using these points. That's 0, 7, and the other point down there is 2, 0. Why these points? On the line, I'm not seeing any other point that we could pinpoint with solid whole numbers, non-fractional. These are good points to use to find the gradient. So y2 would be 0 down here, minus 7, and x2 minus 0, giving us minus 7 over 2. That's our gradient. And then the midpoint now, adding the x coordinates dividing by 2, adding the y coordinates dividing by 2. So 0 plus 2 it is, divided by 2, and 0 plus 7 divided by 2. So it's 1 and 3.5. That's our midpoint. And those are the 3 basic questions they're asking about this line. All right. That's our midpoint. The other 2 parts of the question, however, is something worth paying attention to here. They're asking us, the point minus 2k lies on the line. Determine the value of k. Naturally, at this point, the 2 is the x value, the k is the y value. They have already given us that the equation is y equal mx plus c, and we know that the x is the minus 2 here, the y is the k here, and we already know the gradient. We just found minus 7 over 2. So y equal mx plus c is the equation of our line. We know that. And then we're putting in the gradient, and we know that c was 7. Sorry. We know that c was 7. What we're going to do now is insert the x and the y in their places. So y is k and x is minus 2. See, we're just putting in the information that we know, and we're going to find what k is now. Now, 2 will cancel 2 here, giving you minus 1, and minus 1 times minus 7 is 7. So k is equal to 7 plus 7, giving us 14. And that is our k value. So when you're given a point and it lies on the line, the moment you put the point into the equation of the line along with the other information, we can always find either the x value or the y value if we already have the gradient and point C. All right, the next part of the question now says determine the coordinates of the point of intersection of the line y equal minus 2, y equal x minus 2, and the line shown above. All right, so the line that's in the diagram, right? Its equation was this. Y equal minus 7 over 2x plus 7. And the equation for our new line is y equal x minus 2. Now, those are 2 equations. And again, if you I've gone through the second video on algebra, simultaneous equation is the first thing that would come to mind when we see these 2 equations. Now, because y is equal to both of these expressions, then we can conclude that both of these expressions are equal. Or we can use process of substitution if we want to look at it that way and say x minus 2 can go right here in that y place there, giving us this expression. The fact that we have a fraction in the situation, might be a troubling thing, but we're going to leave it. If we multiply everything through by 2, we would have gotten rid of this fraction. Makes life a little bit easier. But let us say we didn't do that, right? We're going to group the like terms. So the minus 7x over 2, right? We're going to group it with the x on the left side of the equation. Since it's subtracting over this side, we'll add on this side. And the minus 2 here will add on the other side. So what we have is x over 1 plus 7. 7 over 2, x equals 7 plus 2 is what? 9. Now, the reason I wrote this, right, in this fractional way is for us to combine these x's without much of a problem, right? So if you remember, this is an approach that we could do for fractions. We cross multiply so that we can have a common denominator, right? So 2 times x is 2x and 1 times 7 is 7x, right? Let's not forget that x, giving us 2x plus 7 over 2, right? 2 times 1 is 2. And all of that is equal to the 7 plus 2, which is 9. And what we're going to do at this point is multiply both sides by 2. And we'll end up with 9x equals 18. So please follow. I didn't have the arrow at this point to show you that you multiply 2 on the other side. So if you add the numerator there, 2x plus 7x is 9x over 2 equals 9. Then 2 times 9 is 18. When we divide both sides by 2, x is our answer. This approach is really kind of lengthy. It probably would have been easier if from the second stage here, we multiply everything through by 2. Nonetheless, the value of x is 2. And if that's the case, we want to find out what the value of y is. Let's not miss what the aim was again. It was to determine the coordinates of the point of intersection for this line and the other line. When we solve them simultaneously, that's the time when we end up with those values. So we have found that x is 2. What we're going to do now is to plug it into, substitute it into this equation here. So if x is 2, then y is equal to 2 minus 2, which is 0. So when x is 2, y is 0, that should be the point where the two lines meet. Now, for 4 marks, that calculation gives us 4 marks. But I'm just going to show you another way that we could have done this, right? The line y equal x minus 2. Let's say we chose this point here, 5, on the x-axis to insert into that equation of the line. What we'll have is y equal 5 minus 2 and y equal 3. So when x is 5, y is 3. That point is right here on the Cartesian plane. And if we should choose another point, for example, 0, right? If we choose 0, so we choose 5 here and 0 here. If we put 0 into the equation, y equals 0 minus 2 is minus 2. That point is right here. And if we should connect them, the line would go there. Now let's observe. The point that the lines meet is 2, 0. The same thing we got in the previous page there, 2, 0. Now, we have gone through 2 parabolas, right? Well, we didn't draw one of them, but we have answered question from 1. 2 lines. One of them was given 6, 6. Remember that question there? And this one, where one of the line is given and we have to, figure those out from what's given there. And then composite function, inverse function, evaluating function. If we are familiar with all these concepts, then functions and relation will not be a problem on the exam. I can assure you. So we have completed another video And what I'm encouraging you to do, based on what you have seen here, just find another, some other past paper questions, and you will see that the concepts are tested in the same way. All right. So congratulations. We are now at what, 20 questions, and we have a few more to go. But keep following, and it was good having you. We'll see you in the next video.